Good morning. I am Dr. Alok Akwal and I welcome you all on the third lecture of our course Internal Combustion Engine. In this lecture, we will study about the various components of IC engine and the important nomenclature associated with it. Okay, so in this lecture, what we will be studying the basic components of IC engine, which is, I think, a revision of basic mechanical engineering subject that we have already read. We will discuss it in detail. And next is the nomenclature used in IC engine. This nomenclature portion is very important because we are using this nomenclature throughout the subject. Okay, so first of all, start with basic engine component. Okay, so this is the basic figure of our IC engine. Okay, so we will be discussing one by one the various components what we have written, various components associated with this. The first is cylindrical block. Okay, so this portion is our cylindrical block. This lower portion is called our cylindrical block in which the crankshaft rotates. Okay, this is our crankshaft in which the crankshaft rotates. This circle is showing the path of other end of the crankshaft. One end will be the hinge support and other end the path followed by this end is shown by the circle and this cylindrical block in which the our crankshaft rotates. This is very important component because it carries the complete load of our engine. This has to be very strong. Okay, next is our cylinder. Above the cylinder block there it is cylinder is attached to it. This portion is called cylinder. The color I have made same so that it is easy to understand. This portion is called cylinder. Okay, this is located over the cylindrical block in which piston move. Inside this cylinder the piston will reciprocate. Okay, next is piston. This is again a circular cross section component which reciprocates inside the cylinder. It will move up and it will move down and it will be operated with the help of this crankshaft via connecting rod and crank pin. Okay. Next one is combustion chamber. Combustion chamber is a space between the upper portion of the piston and this cylinder head. This portion is called cylinder head. जो cylinder का top portion we call it as a cylinder head. So the space available between the upper portion of the piston and cylinder head is called combustion chamber. This is a variable volume uh, portion. Okay, the volume of this combustion chamber will continuously changes when piston moves from uh, top to bottom and from bottom to top. It is not a fixed quantity portion. That is combustion chamber. Next one is intake manifold. Here you are seeing this pipe. Okay, this pipe is called intake manifold. With this intake manifold, the air or mixture of air fuel will come from outside to the combustion chamber. It will be a pipe, it will be a path followed by the air fuel mixture or air to induct the charge from outside world to the combustion chamber is called intake manifold. Next one is exhaust manifold. After the combustion completed, there will be a waste gas. We called it as the exhaust gas, and to remove this exhaust gas from the cylinder, we took the help of exhaust manifold. This is again a pipe which is used to remove the exhaust gases, the used gases, the waste gases from inside the cylinder to the outside atmosphere. Next one is inlet and exhaust valve. This one is inlet valve and this is exhaust valve. It is its function is to operate with the help of crankshaft and it guides when the air fuel mixture is required it will open and when the air fuel mixture is not required it is closed. Again when we have to exhaust these gases from cylinder to the outside world, this exhaust valve is open and rest of the time it is closed. So these are the valves which is operated by the crankshaft and it decides when the air fuel mixture or air will come inside the cylinder and this exhaust valve governs when the combustion product which is available inside the combustion chamber will go out of the cylinder. Okay, so this is again very important component. of this IC engine: inlet valve and exhaust valve. Next is spark plug or fuel injector. See, I had written spark plug or fuel injector because in case of IC engine, they have seen in the classification that on the basis of ignition system, IC engine is classified in two different types. First one is spark ignition engine and second one is compression ignition engine. So in spark ignition engine, spark plug is required, and in compression engine ignition engine, fuel injector is required. So depending upon which type of engine we are talking, it is spark plug, either spark plug or it is either fuel injector. Okay, so here it is saying spark plug, so it can be said that this is a structure of IC engine. Rest of the things will be same. In place of spark plug, it will be a fuel injector when we are talking about compression ignition engine. Next is connecting rod. This connecting rod is a rod which connect piston with crankshaft. Okay, so uh, what it is doing, it is used to convert this reciprocating motion of piston to the rotary motion of crankshaft. Okay, so this is connecting rod. Next one is crankshaft. This portion is crankshaft. Okay, crank and crankshaft combination. This is in a circular motion. In the circular motion, where this reciprocating motion of piston via connecting rod converted into rotary motion. Next one is crank pin. The pin which connect the crank to the connecting rod is called crank pin. The pin which connecting rod to the piston is called gudgeon pin. Camshaft and its mechanism. Camshaft and mechanism is very important, which is not shown in this figure, as it is located above the valves. Okay, there is arrangement, cam arrangement over the both the valves, which decide when the inlet valve will be open and closed and when the outlet or exhaust valve will be open and closed, and this is governed by the rotation of crankshaft. Okay, so there is a link between crankshaft and this inlet and outlet valve with the help of camshaft and its mechanism. And finally, the flywheel. The function of the flywheel is to store energy and deliver it when required. When engine is not working or when engine is under some serious condition, the energy is taken from the flywheel. Otherwise, the energy which is engine produce, a part of energy is getting stored in the flywheel. So these are the important component of IC engine. Next one is nomenclature. First is cylinder bore. Cylinder bore, it is denoted by small d, which is a nominal inner diameter of cylinder. The inside diameter of the cylinder is called cylinder bore. Piston area is, again we consider generally piston cylinder bore and area diameter of piston same, though it is a little bit clearance but we neglected. So the area of the piston will be pi by 4 d square. Next is stroke. That's the important term is stroke. It is the nominal distance through which a piston moves between two consecutive reversals. Means when piston is moving up from most upward side to the most downward side, the distance traveled in this position, in this part, when piston moves from top position to bottom position, it is called stroke. Okay. Next is stroke to bore ratio. Bore, we have seen that nominal inner diameter, stroke, that is L. When we are talking about the ratio of L by D, we call it a stroke to bore ratio. And on the basis of this ratio, we decide the size of the engine. If D is smaller than L, we call it as an under square engine. When D is greater than L, we call it as an over square engine. And when D is equal to L, we call it a square engine. Again, important term is dead center. Dead center means the point from where the piston changes its direction. Okay, when piston is moving up and suddenly it reverses its direction from up to down, that is called top dead center. And when piston is moving down and when it reverses its direction from top to up, we call it a bottom dead center. So there are two type of dead center. One is top dead center and one is bottom dead center, and it is the point from where the piston reverses direction during the completion of stroke. Okay. Next important, very important term is displacement or swept volume. It is the volume swept by the working piston when it travels from one dead center to another dead center. Means if suppose the piston is in the top dead center, in the topmost position, and will travel from top dead center to bottom dead center, it will travel some distance that is equal to stroke length and with this it will cover some area. So length into area will become volume. The volume covered by piston when it moves from one dead center to another dead center is called swept volume. So if you consider that there is a diameter of bore is d and stroke length is l, then swept volume will be area into volume will be area into length, and it will be pi by 4 d square into l. Cubic capacity or engine capacity means it depends upon the swept volume and the number of cylinder. See, if there is a single cylinder engine, the cubic capacity will be pi by 4 d square into L. But if it is a multi-cylinder engine that we have seen, that engine, IC engine is classified on the basis of number of cylinder. Single cylinder engine is called, if there is a single cylinder, we call it a single cylinder engine. And if it is more than one cylinder, we call it as a multi-cylinder engine. So on the basis of number of cylinder, engine capacity is decided like cubic capacity. It is denoted by cubic capacity. सीसी जो हम इंजन का बोलते हैं कितने सीसी की गाड़ी है, मारुति 800 सीसी की गाड़ी है. So it is not like one cylinder has a volume of 800 cubic centimeter. It is depend upon the number of cylinders. Generally, Maruti is 800 cc engine with 4 cylinders. So each cylinder will be of 200 cc. So cubic capacity is defined as the swept volume of the engine into the number of cylinder. Swept volume of cylinder into the number of cylinder. K denotes the number of cylinder. Okay. So this is again very important things which we are not knowing very much. That is, what is cubic capacity? It is the swept volume multiplied by the number of cylinders. Next is clearance volume. Clearance volume is the volume remains at the top of the engine when piston is at top dead center. जब पिस्टन पूरा का पूरा टॉप डेड सेंटर में है, उसके बाद जितना वॉल्यूम बच जाता है, that is called clearance volume. Then what will be the cylinder volume? Cylinder volume is when the piston is at the bottom dead center. So it will be the combination of total volume. Yeah, cylinder volume is the combination of swept volume and clearance volume. Because clearance volume is the volume remains at the top of the cylinder when piston is at top dead center, and when piston moves from top dead center to bottom dead center, it will swept the volume that is equal to swept volume. Okay. So total volume or cylinder volume is a sum of swept volume and clearance volume. The last and very important term is compression ratio. This is the most important term which governs the overall things of the IC engine. So compression ratio is the ratio of total cylinder volume, that is V, when the piston is at the bottom dead center. जब piston bottom dead center में तो कितना volume होगा? That is V to the clearance volume. जब piston top dead center में तब कितना volume होगा? So it is V by R, it is denoted by small r, and it is V by Vc. This V can be written as from here Vs plus Vc, and when we solve it, it will be 1 plus Vs by Vc. So this is the compression ratio. It is very important. Uh, it is very important term as it decides the. We will see in coming classes that it will decide the efficiency of the engine. The efficiency of the engine is mainly depend upon the compression ratio of the engine. Okay, so this is the nomenclature, various important terms that are associated with our IC engine that we have to keep in our mind, and we have to know each and every term in very much detail, and we will use this term throughout the coverage of the course. So in today's class, we have seen the basic engine component and the various nomenclature associated with it. So this is all for today's class. Thank you. In next class, we'll start with working of IC engine. Okay. Thank you, class.